Welcome to sections 2.1 and 3.1. Okay, so we're going to talk about secant lines and average rates of change, tangent lines, and the derivative of a point. Okay, do you remember when we were looking at the puppy chart? Okay, suppose we just take, for example, the curve, the top curve, growth curve, okay, of this breed, just the top one. Right, and then let's just isolate that and take that curve. And then what we're going to do here is, suppose we want to find out what is the growth rate from the interval 0 to 6 months, 6 to 12 months, and maybe 12 to 24 months. So from a year, 1 to 2 years. And this is like the first 6 months, the second 6 months. Okay, so if we take the first interval, then so the growth rate from the first 6 months would be just the slope of the line that is secant to this curve. Okay, so really it's the slope of the red line. Okay, and then for from 6 to 12 months, it'll be the slope of this secant line. Okay, and then from 1 year to 2 years, it'll be the slope of the blue line, secant to this curve right here. So let's go ahead and isolate that curve and see how it looks like. All right, from here, what we'll do is we'll just get the slope of the line secant to the curve from 0, the interval from 0 to 6. And how do we do that? Right, so we take the slope m. Let's say that's from 0 to 6, right? It'll be the slope of the line that's secant to the green curve. So how do we find the slope? It's change in y over change in x. So in this case, the change of y is the change in the weight. So the intervals here, the coordinates here are 0, 0. And then at this end point of this end of the line, it'll be 6, 47. Right, so now we're going to do 47 minus 0 divided by 6. So that's this interval from 6 minus 0. Okay, because if you will recall, it's going to be y2 minus y1 over x2 minus x1 if you designated this as your x1 y1 and this is your x2 y2, and that's going to be 47 over 6, which is approximately maybe, okay, what is 47 over 6? That's roughly 7.7. So how do we determine the rate? It's going to be 77.7 kilograms per month. So as you can see, in the first 6 months of the growth rate is really fast. Now let's look at the next one, the next interval. Okay, so now we're going to look at the interval from 6 to 12 months. So what are the coordinates here? We said it's 47, 6. And here, that's going to be, oh, by the way, oops. Right, I meant to correct that, so I did change it. It's from, the coordinates are 6, 47, and then 12, 70. Okay, so what is the slope now of this interval? Or rather of this line secant to the green curve. So the slope, so this from the interval 6 months to 12 would be, again, delta y over delta x. So that's going to be the change in y. So 70 minus 47 divided by 12 minus 6. And what do we get here? It's going to be 23, right? 23 over 6, which is approximately 3.8 kilograms per month. So the second half of the growth rate of this puppy has declined. It was faster in the first 6 months, but in the second interval from 6 months to 12 months, then the growth rate has kind of decreased. Because now, if you can see, the slope of this line is not as steep as the red line. Then if we keep going further, the more mature they are, the growth kind of tapers. All right, so now that we're on the last interval, so recall that what are the coordinates here? It's going to be 1270, right? And then this is going to be 24, and then what's the weight? 75 kilograms. Okay, so let's see. So the slope on the last interval from 1 to 2 years, and we got to be consistent with our unit of measure. It was going to be 75 delta y minus delta x, so 75 minus 70 divided by 24 minus 12. So that's going to be 5 over 12, which is what? It's just approximately 0.4 kilograms per month. So as you can see, the growth rate has kind of slowed down in the last, in this, I guess, second half of the first 2 years of a dog. So what we're looking at now is you have a curve, the green curve, okay? And then average rates of change, therefore, would be the slopes of the lines secant to the curve at a given interval, like from 0 to 6, 6 to 12, and then 12 to 24. I mean, you can take other intervals, like say the first 3 months. So if you're at the first 3 months, then you're going to have a different secant line right there. So this is going to have a different secant line, and it will have a different slope for this secant line. Okay, so let's move on to the next example. This is just a formal definition, all right? So by definition, the average rate of change of any function y equal to f of x with respect to x. In our case, our x's were months and the y values were kilograms. So over the interval, say from, you remember, 0 to 6, so that's the same thing. So it's going to be delta y over delta x, which is the y2 minus y1 over x2 minus x1. Now remember, that could also mean that it's the quotient f of x sub 1 plus h minus f of x sub 1 over h. Now what is h? H is just the distance between x2 to x1. So in the previous example, that was 6 months. Okay, for every 6 months or 12 months, etc. So let's take the first example, example 1. You're going to have find the average rate of change of the function over the given interval, okay, of this cubic function on the interval 6 to 8, or the interval from, and also the interval, rather for B, it's minus 4 to 4. So how does this graph look like? So let's go ahead and look at the second slide. Okay, so find the average rate of change of the function over the given intervals. So let's see, in the interval from 6 to 8, okay, then we look at what's the y value corresponding to x equal to 6, and what's the y value corresponding to x equal to 8. So we take the first point and then label it x1, y1, and then the second point is x2, y sub 2. So the average rate of change of f of x on the interval 6 to 8 would be delta y over delta x, and so that's the change in y's over the change in x, so that's f of 8 minus f of 6 divided by 8 minus 6. And all you have to do is just plug in 8 into the function, and then 6 into the function, and then take their differences. And then what would be the final answer here? So if you work all this out, then the final answer would be 296. Of course, that is really a very, very large slope, but because of the way this was scaled, it could be almost really vertical, but it doesn't show here on our curve because of the way it's scaled. Okay, and also if you note this one, this blue curve is really not passing through the origin, but because the way that we scaled here is kind of squishy, don't see it, that it's not passing through the origin. Make sure, because look, the y-intercept is at 2, so you really can't see 2 on the scale from 0 to 500. Okay, all right, and so the next slide the next video is going to be finding the average rate of change on an interval from -4 to 4. Okay, all right.